there, data enthusiasts. Ever wondered how Netflix knows exactly what you want to watch next, or how your favorite online store always seems to recommend just the right products? The secret sauce behind these amazing feats is data modeling and machine learning. Welcome back to Knowledge Academy's YouTube channel. Today, we're pulling back the curtain on this fascinating topic. Ready to unlock the power of your data? Let's dive in. In this video, we'll explore the essentials of data modeling, including the different types of models, how to use them, and their real-life applications. But first, let's clarify what data modeling is and why it's so important. Data modeling is the process of creating a mathematical representation of the relationships between various features in your dataset. This model can then be used to make predictions or understand underlying patterns. In the context of machine learning, data modeling involves selecting and training algorithms to learn from your data. The key objectives of data modeling include prediction, classification, clustering, anomaly detection, prediction, which is forecasting future outcomes based on historical data, classification, it categorizes data into predefined classes, clustering, that is grouping of similar data points together, anomaly detection, this is identifying unusual patterns that do not conform to expected behavior. Let's break down each of these objectives and see which types of data modeling fall into each category. First, we have prediction, which involves forecasting future outcomes based on historical data. This is primarily achieved using regression models. This includes linear regression. This predicts a continuous outcome based on one or more input features. For instance, predicting house prices based on features like size, location, and number of bedrooms. Time series analysis. This is used to predict future values based on past data points. For example, forecasting stock prices or sales over time. Imagine you're a real estate agent. You want to predict the price of a house based on its size. By using linear regression, you can create a model that predicts house prices based on their area. This helps you give accurate price estimates to potential buyers. Another example is predicting future sales for a retail store based on past sales data, which can help in inventory management and marketing strategies. Next, we have classification, which involves categorizing data into predefined classes. This is typically done using models like logistic regression. This is used for binary classification tasks, such as predicting whether an email is spam or not. Decision trees classify data by splitting it into subsets based on feature values, used in scenarios like diagnosing diseases based on symptoms. Support vector machines, SVM, classify data by finding the optimal hyperplane that best separates different classes. Consider a medical diagnosis scenario. A decision tree can be used to diagnose a disease based on symptoms. Each node in the tree represents a question about the patient's symptoms, and the branches represent the possible answers. The leaves of the tree represent the final diagnosis. Another example is email spam detection, where a model can classify emails as spam or not spam based on features like word frequency and email length. Next is clustering, involves grouping similar data points together without prior knowledge of the group definitions. Clustering models include K-means clustering. In this, it partitions data into K-clusters, where each data point belongs to the cluster with the nearest mean. Hierarchical clustering. This builds a hierarchy of clusters by either merging or splitting existing clusters. For instance, in customer segmentation, a retail company might use clustering to group customers based on purchasing behavior. This helps the company tailor marketing strategies for different customer segments, enhancing customer satisfaction and increasing sales. Another example is grouping news articles based on their content, which can help in organizing and recommending news to readers. Lastly, anomaly detection is about identifying unusual patterns that do not conform to expected behavior. This is crucial for applications like fraud detection and network security. Models used for anomaly detection include isolation forest. This detects anomalies by isolating observations in the data. One class, SVM, it classifies data points as similar or different from the majority of the data. In a banking context, anomaly detection models can be used to identify fraudulent transactions. By analyzing patterns from past transactions, the model can predict whether a new transaction is likely to be fraudulent, helping banks prevent fraud. Another example is network security, where anomaly detection can identify unusual activities that might indicate a security breach. So, data modeling is crucial for several reasons, some of which are: first, to improve decision-making, as models provide insights that help businesses make informed decisions. Second, for efficiency, automated models can process large amounts of data quickly, saving time and resources. Third, for scalability, models can be applied to large datasets, making them suitable for big data applications. Next is accuracy, since well-trained models provide accurate predictions, which are essential for applications like finance, healthcare, and marketing. Understanding these benefits underscores the importance of mastering data modeling techniques. For example, in finance, accurate models can help predict stock prices and manage investment portfolios. In healthcare, models can assist in diagnosing diseases and planning treatments. And there you have it, a comprehensive look at data modeling for exploratory data analysis with machine learning. From understanding different types of models to their real-life applications and best practices, we've covered all the essentials. This is just an overview of data modeling, about what we will be dealing with in the upcoming videos. Data modeling is a big topic, so every model that we discuss in this video, we will be learning about each of them in a separate video. Next, we will be learning about supervised learning in machine learning and how these models are applied in it. If you enjoyed this video, hit the like button and subscribe to our channel for more exciting and informative content. Don't forget to turn on notifications so you never miss an update.